These could be trees.
Well, let's look at a close-up. Let's look at the next image, number 16.
This is like a close-up. So we see lots of small images. We see the shadow casts as well, so we can tell that they're actually extended above the ground by the shadows they cast. And we can also see on the right-hand side, we have what you can still see the same dendritic pattern, so it looks like it's like foliage all melded together. That's
now these are huge, aren't they?
For example,
these are like a mile across or something, aren't
they? A kilometre, yeah.
Sorry, I beg your pardon, a kilometre.
The one on the bottom left, the larger of the ones, is a kilometre across. And so,
but there are trees on Earth that are almost that big, aren't there?
Yeah, there's the largest tree. Well, it's actually the largest tree up until a few years ago on Earth was about a kilometre across, actually, and it was a banyan tree.
Banyan,
and it was in botanical gardens in India. It's currently actually because of how it works is basically it branches out and kind of grows, and has multiple kind of branches, multiple trunks, I should say. So rather than it being like a tree, as like an oak tree, it has multiple trunks coming out, but it's the same life form. It's a single life form. What happened with the one in India? They damaged it, so it's become multiple life forms. It's kind of branched out, so it's technically smaller.
It's branched out. It's branched out on its own.
But basically, that tree, when it was actually one organism, was the same size as that particular object. So there's a precedence there for a tree being that big.
Well, Arthur C. Clarke, apparently. Well, you tell the story.
Yeah, Arthur C. Clarke basically was spoke out openly in the media about that particular image, that particular photograph image from MGS showing, basically it was evidence of trees on Mars, shrubs on Mars at least anyway, and they've become known in the community of researchers as Clarke's trees for that reason.
And of course, late great Arthur C. Clarke, it was he wrote 2001: A Space Odyssey, but also he was responsible for geostationary satellites, wasn't he? Because he posited the idea in a novel, and then later on, when companies tried to patent the idea, they found that they couldn't because it had already been described in a novel tens of years beforehand. And so there was no patent.
It was a visionary, really. It was like so many science fiction authors are, like H.G. Wells. So Arthur C. Clarke was basically describing things that scientists would then decide, okay, we can really do something with this. He was really coming up with the ideas.
And Philip K. Dick, he's one of my favourites.
Yeah, that's another good one too.
Fantastic, man. Okay, so we've got some evidence then of living organisms.
Well, to say evidence, that particular image we just showed was basically, it looks like trees. If you took the same photograph on Earth, and actually, I'll keep doing this to people. I'll keep showing the photograph to somebody. I don't tell them it's on Mars and say, what do you see? It's a satellite photograph, what do you see? And they'll tell me it's trees. If you tell them it's Mars, oh no, it can't be trees.
Let's go back to 16 again. Let's have another look at it.
Yeah, if we treat Mars with the same criteria as we treat Earth, forgetting that we don't know there's life on there for a second, you will make the assumption that it's just trees.
Well, let's play devil's advocate here, Anthony. What if there is no life on Mars and there's no organic life of any kind on Mars? What is it?
It must be something that's created by a geological process.
But it's above the ground. We know that because of the shadows.
It'd be unusual. Either way, it's an unusual geological feature if it's a geological feature.
Some sort of extrusion.
Yeah, it'd be fascinating. I mean, geologists would be fascinated by this, which begs the question.
They could probably go there with a saw, cut it down, and make a house with this geological extrusion.
Because it's so unique, it would beg the question why NASA have not gone back and investigated this further and taken more photographs of that particular area and snapshot and basically see what it really is. The two ways one way you can actually look to see if it's actually biological material, or you basically determine which one it is. If you go back, say a few months later, and keep going back to keep taking photographs,
and seeing if it changes with the season.
In the shot, if it changes with the seasons, it's evidence that it's biological. If it stays static and maybe even just reduces or something, and maybe it's eroded, it's evidence that it's geological. This is one of the problems what NASA have not being consistent in investigating this evidence for life on Mars. They haven't gone back to do the work afterwards to verify whether it is geology or whether it's biology that are causing these structures.
So do you think they might be going back and just not letting us know? Because their orbiters are still in orbit, aren't they?
Yeah, I mean the Mars Global Survey is still. I think it got there. Well, this was 1999 with that photograph taken. That's still up and running. Still sending data back.
So do you think they're not sending it?
I met the speculation. I postulate that basically they have been looking at these stuff in
Anthony, we're going to go for another break now.
Okay.
Once again, if you'd like to text in your comments or questions for Anthony Beckett, please do so now.